Good morning, everyone. Welcome back, and thank you for joining us. We are so glad that you're here. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, the Science and Technology channel.
Yeah, and we are talking about an interesting story today, especially if you live in New Jersey. This is kind of crazy. Maybe lightning doesn't strike twice, but I don't know about meteorites. But here we go. Oh, there it is right there.
A meteorite that blasted through a New Jersey roof, an astronomical curiosity, carried a startling secret: evidence of ancient salty fluids and complex organic chemistry inside a primitive asteroid. Sealed inside were traces of ancient salty fluids and organic chemistry that may help scientists reconstruct how primitive asteroids once processed some of the raw ingredients associated with life. Would you like to know more?
That is crazy. I mean, if that had hit somebody and walking around outside, it probably would have killed them.
Yeah.
You think? I mean,
Yeah.
that's nuts. The meteorite landed in Hillsborough, New Jersey, after a daytime fireball raced across the New York City region on July 16th of 2024. The meteor produced a sonic boom as it passed just south of the Statue of Liberty before breaking apart high above the ground. Could you imagine? I mean, if that could have been just crazy. With all
Yeah.
the people that are around.
Yeah.
It's just nuts. An international team has now published the first detailed analysis of the recovered material in Science Advances on July 15th of this year.
Quote, a forensic study of the fragments revealed that they contain preserved bits from near the surface of a primitive asteroid where it experienced concentrated salty fluids, a process not previously known from this type of protoplanet world, said lead author and meteor astronomer Peter Jeniskins of the SETI Institute and NASA's Ames Research Center in California's Silicon Valley.
Okay, the original object was roughly the size of a heavily packed airline bag. It struck Earth's atmosphere at 32,000 miles per hour. That's fast, generating a bright meteor visible across several states. City observers in New York, New Jersey, Connecticut, Rhode Island, and Pennsylvania reported the event to the American Meteor Society. 16 people in the New York and New Jersey, New York and New Jersey also felt the shockwave. I'll bet.
Yeah, and this just reminds us, Scott, that the Perseid meteor shower is going to start this week.
Tomorrow night, right?
Yeah,
The
in
12th?
the next 3 or 4 nights, and the best viewing is Wednesday the 12th.
Gotcha.
So get out to a dark area, and so you can see it. And if you're in a dark area, it could be anywhere from 50 to 100 meteorites per hour.
That'll be wild.
Yeah. Okay. The incoming rock was too fragile to remain intact. It fragmented rapidly, and the visible meteor disappeared about 22 miles above Earth. Doppler weather radar at Newark Airport later detected a narrow trail of falling debris stretching from Staten Island into New Jersey.
Okay. Hillsborough sat near the end of the debris field where the largest surviving pieces were expected to land. Yet only one meteorite was recovered. It was found because it crashed directly through a house. I wonder where the rest of them.
Go ahead.
In the ocean, maybe? I don't know. In the harbor?
Yeah.
Crazy.
The homeowner described the impact, quote, I was at home at the time, heard a loud crash, and found a hole in the ceiling of the master bedroom. I smelled a strong sulfur odor. At that point, smelling sulfur, I would have ran, thinking it was a demon that, crashed in there. That's what I would have done. And saw many black fragments along with debris and black dust that covered my bed, carpet, and surrounding areas.
Wow. Okay, his next actions proved scientifically important. Rather than handling the fragments with bare hands or leaving them exposed, he documented the room and collected the pieces with disposable gloves and aluminum foil before sealing them in glass jars. That quick response limited contamination from skin oils, dust, moisture, and other terrestrial material.
Carbonaceous chondrites are among the most primitive meteorites known. Unlike rocks that were heavily melted and reworked inside planets, they preserve material dating back to the early solar system, when planets and asteroids were still assembling. Many contain water-altered minerals, carbon-rich compounds, and amino acids, making them especially valuable to scientists studying the chemical conditions that preceded life on Earth.
The Hillsborough meteorite belongs to the CM group, named after the Meghai meteorite that fell in Ukraine in 1889. CM meteorites are usually classified according to how extensively their minerals were changed by liquid water inside their parent asteroid.
Mike Zolensky, a meteoriticist at NASA's, I didn't even know that was a word, at NASA's Johnson Space Center, is in Houston, and a co-author of the study found that Hillsborough material had experienced more water-driven alteration than a typical CM2 meteorite. Researchers classified it as a CM1.5, placing it between the more altered CM1 type and the less altered CM2 type. So CM1/2.
That makes the fall exceptionally rare. Hillsborough is only the 22nd observed CM meteorite fall and just the second witnessed fall of a CM1/2 carbonaceous chondrite. The first was the Kolang meteorite, which fell in North Sumatra, Indonesia in 2020. Every other witnessed CM fall has been classified as CM2, while no CM1 meteorite has ever been seen falling in Earth or to Earth. Interesting.
The most surprising discovery came from tiny salt-rich CM1 fragments embedded within the meteorite. Zelensky and colleague Zhengmi Han concluded that these pieces may have formed near the surface of the parent asteroid, where liquid water evaporated and left behind increasingly concentrated brines.
That process resembles what happens when a salt lake or shallow pool dries on Earth. As water disappears, dissolved chemicals become more concentrated, potentially creating conditions that favor unusual reactions between minerals and organic molecules.
Scientists had already found evidence of briny fluids in another primitive meteorite group known as CL or CI carbonaceous chondrites. The CL designation comes from the, or CI designation comes from the Ivuna meteorite, which fell in Tanzania, 1938. Similar materials later returned directly from asteroid Ryugu by JAXA's Hayabusa, that's Japan's aeronautics, Hayabusa 2 mission, and from asteroid Bennu by NASA's OSIRIS-REx mission.
Those asteroid samples arrived on Earth under tightly controlled conditions, giving researchers uncontaminated evidence that salty water once moved through primitive asteroid material. The Hillsborough discovery suggests that concentrated brines also developed in CM asteroids, broadening the range of early solar system environments where this chemistry may have occurred.
Researchers are now identifying the salt minerals in the Hillsborough fragments and comparing them with material collected from Ryugu and Bennu. Brines are particularly interesting because they may encourage chemical pathways relative to prebiotic chemistry. Concentrated salty fluids can keep phosphate dissolved, bring reactive compounds into close contact, and promote interactions between organic molecules and newly forming materials. That makes sense. That all makes sense.
Okay. The meteorite also held a diverse collection of soluble organic compounds. Their chemical range reinforced the conclusion that the rock had been altered by water more extensively than most CM meteorites. Scientists also found numerous amino acids, the molecule building blocks used to make proteins in living organisms. Their presence does not mean the asteroid contained life. Amino acids can form through non-biological chemistry, including reactions inside asteroids. Their importance lies in the showing that space rocks can manufacture and transport complex organic material. Interesting.
Organometallic compounds were present as well. On Earth, this broad class of molecules includes compounds that play critical roles in blood and photosynthesis, although the compounds in the meteorite formed without biology.
Astrobiologist Danny Glavin of NASA's Goddard Space Flight Center in Greenbelt, Maryland, and his colleagues in Goddard's Astrobiology Analytical Lab concluded that CM-type bodies could have supplied the Earth, or the Earth could have supplied the early Earth with amino acids, carboxylic acids. I'm hoping I'm pronouncing that right.
Yeah.
And other soluble organic molecules.
Such deliveries may have enriched Earth's prebiotic chemical inventory before the first living systems emerged from the water. Who knows? The analysis indicates that the Hillsborough meteorite's complex amino acid mixture formed inside its parent asteroid, likely with assistance from brine chemistry.
Several Hillsborough fragments will now be preserved at the American Museum of Natural History in New York City, allowing future researchers to study the meteorite with analytical techniques that may not yet exist. Quote, "We are thrilled that nature delivered such a precious asteroid sample on our doorstep." That's said by curator Denton Ebel. Yeah, talk to the guy whose house it crashed through. Guess imagine he's probably not too happy about it. But
Yeah.
maybe it is. Maybe it'll be a stop on the tour bus or something. Maybe you'll make some money out of the deal. So, but yeah, how cool. I guess. I mean, it just that they're able to study this stuff is fascinating to me. I find all these organic molecules. So, okay, good story.
All right, folks, thanks for joining us. We'll catch you in the afternoon.
Take care, everyone. Have a great morning. Thanks.